Okay, welcome everybody and welcome to this new video. Thank you very much for reaching out to this video. I'm the Successful Electronics who's post on great electronic content. I want to say thank you for reaching out in this video. Actually, in this video, I'm going to be discussing how the AND gate works. I'm going to be explaining the AND gate procedure. I'm going to be explaining totally how the AND gate works in a circuit manner. I'm going to be explaining this AND gate in a circuit manner using a lamp as my load, using two switches and using one cell battery. So important that you stay with me to the end of this video. Don't skip anywhere of this video to have great insight of how the AND gate actually works, and let's go to the explanation. Stay tuned. Okay, welcome back. Now actually in this illustration I'm going to be talking about the AND gate. I'm going to be explaining some kind of cool tips, some kind of great tips about the AND gate before I go to the circuit connections. Okay, now you can see now this is the AND gate diagram. This is the output, which is indicated as F, and this is the input, which are A and B. This is the input. The AND gate have a minimum of two inputs actually. Yeah, this is the two input and this is the one output, and this is the truth table which I'm going to be discussing later in this video. First off, let's focus on the diagram of the AND gate. Okay, now I have a little description, I have a little definition about the AND gate. Now actually the AND gate has a minimum of two inputs, and the output is high only if both inputs are high. Yeah, that's the description which I want to tell you about. The output is high if only the two inputs are high. If either of one of the inputs are low and the other is high, the output is gonna be low. Now let's go to the truth table connection. Sorry, the truth table illustration. I have to just zoom it in for you to be able to see it more properly. Okay, now this is the truth table. This is the two input right here, and this is the output, which is indicated as F. Okay, now if either of the two inputs are low, the output is gonna be, if one of the inputs is low and one of the input is high, the output is gonna be low. If one of the input is high and the other of the input is low, the output is still gonna be low. But if either of the input, two of them are high, then the output is gonna be high. This description is very simple. If one of the input is low and the other of the input is high, the output is gonna be low. The only case while the output is gonna be standby high is when the two either inputs are high. I want you to understand me very well and very clearly. I'm gonna come again so you can get this very precisely and very understanding. Okay, now I come again. If two inputs are low, the output is gonna be low. If one input is low and one input is high, the output is gonna be low. If one input is high and the other input is low, the output is still gonna be low. But if the two inputs are high, the output is gonna be high. This is the great description which I want you to understand. Now I'm going to move over into the clip which I'm going to be explaining how the circuit relates to the AND gate, which I mentioned earlier in the intro video. So let's go to that clip. Welcome back from that short clip. Now this is the circuitry which I'm going to be explaining how the connections is done and how it's related to the AND gate. Okay, now this is my cell battery. This is my two cell battery right here, and I have my load right here, and I also have my two switches right here. As I said earlier about the truth table, if one input is low and the other output is high, entirely the output is going to be low. The only time that the output is going to be high is when two inputs are high. So same as this circuitry, if one switch is closed and the other switch is opened, the circuitry is not going to be powered on, thereby is not going to turn on my lamp right here, which I indicate as a load. So if this switch is closed and the other switch is opened, power is not going to flow through the two switches, thereby turning on the load. Now this is how it functions. If this switch is closed and this other switch is open, let me zoom it in for you to be seeing it well. If this switch is closed and this other switch is open, power flows from this switch through this switch and stops here cause this switch is not closed. But if this switch is closed also, I'm going to indicate it like this. If this switch is closed also together, Power flows through this switch and also flow through this switch and then flows to my lamp, thereby powering my lamp, and then we can say the circuit is complete. But if one switch is closed and the other switch is open, power flows from the first switch and stops in the other switch which is open, thereby the circuit is not complete. If this switch is closed and this switch is open, power flows like this and stops here, cause it cannot flow through the other switch cause the other switch is closed. This is how it functions. This is a simple scheme. This is a simple relation how it relates to the AND gate. I'm going to take it again for you to understand it very much better. Now listen very carefully. This is my circuit diagram, and I have my battery right here, and I have my load right here, and I also have my two switches right here. Imagine that these two switches opened. Yeah, this two switches open, thereby off. That the other name for open is actually off. Okay, now if this first switch is closed, I'm gonna name it S1. I'm gonna name the second switch S2. If this S1 switch is closed and the S2 switch is opened, power is going to flow through the first switch but stops in the second switch, thereby the circuit is not complete. But if the two switches are close together, power flows through the first switch and also flows through the second switch, thereby completing the circuit, and thereby we'll say the circuit is complete. As I explained earlier in the truth table, that if one part of the input is low and the other part of the input is high, the output is going to be low. Only if the two outputs are high, that's when the output of this AND gate is gonna be high. This is a simple illustration which I want you to understand. I'm gonna move over to the practical connections, or how I will connect it practically using the real component, and I hope you will enjoy it much better. Thank you very much, and let's go to the second clip. Stay tuned to this video and subscribe to this channel. Okay, welcome back, and actually this is the circuit diagram. Now I've connected everything together. I wanted to make it to the breadboard, but I actually say that I should connect it broadly so that you can be able to see it and understand it very much better. And you can see my two switches right here. This is the S1 and this is the S2, and you can also see my battery here. I use a 500 mAh 9 volt battery, and you can see my 3 volt LED right here. I wanted to use a resistor so that it can be able to limit the current so that the bulb will not blow up. But I actually connected the resistor on my circuit diagram, but I didn't connect the resistor right here because when I was connecting the circuit, I almost forgot to add the resistor. And when I remember that I haven't added the resistor, I've already gum and glued everything up, so it was like I forgot to put the resistor. But actually, since I'm not on the bulb for a long period of time, I just want to explain how the circuit works in this video for a short period of time. I don't think the resistor is actually necessary because the resistor limits the current of the battery not to blow the bulb if the bulb is meant to be turned on for a long period of time. But actually, since in this video I will not be on the bulb for a long period of time in my explanations, so the resistor is not needed in this circuit. Okay, as I say, this is my 3 volt battery. It is the positive connection, and this is the negative connection. You can see it right here very clearly. And actually, this is my battery right here, which is the supply of the voltage. Actually, I didn't put a clip here. I just connected properly. Okay, now you can see this S1 switch and the S2 switch. As I explained earlier in my later video, I actually said that if the first switch is turned on and the second switch is turned off, the output is gonna be low, but only if the two switches are turned on. That's when it's gonna turn the circuit on, and I said that it's gonna open the circuit, and we can see that the circuit is complete, and thereby turning on the LED. So if one switch is turned off and the second switch is turned on, the circuit is not going to power. Only if the two switches are turned on, that's when the circuit is going to light up. Okay, this is a simple description which I wrote about here. Actually, this is a practical, is a school practical which our sir said we should do. So this is how we arrange it and we present it to him. So I just leave it like this, and I say I'm going to use it to make a video. You can see the diagram right here. Just have to zoom it in for you to see it well. Okay, this is, you can see the diagram right here. You can see the truth table right here. You can see a little bit of description right here. So actually, if you turn the first switch on, let's say both switches are turned off. If you turn the first switch on and you turn the second switch off, the bulb is not going to light up. Only if you turn these two switches on, that's when the bulb is going to light up. So I'm going to turn on this switch. I'm going to turn off the two switches, and right now I'm going to turn on the first switch. I'm going to turn on the second switch, and then the bulb lights up. I know it can kind of be too much bright because of I didn't put a resistor to limit the current, so it's kind of too much bright, so I could zoom it out a little bit. So yeah, so this is the simple illustration which I said I'm going to make for you to understand it much better. So if you on the first switch and you didn't on the second switch, the power is not going to flow through the circuit, thereby it's not going to turn on the light. The only way the bulb is going to turn on is when the two switches are turned on. So I think I break down this practical AND gate illustration very well. Thank you very much for watching this video. If you really like this video, support me on Patreon and also subscribe to this channel. Give this video a thumbs up, and also thank you very much for reaching me my first 1.8K on my video explaining how to make a 4x5 timer oscillating frequency generator. Thank you very much for watching this video, and I'll catch you guys at the next one. Peace out. And also I would like you to subscribe to this my creators of electronics, which I also learn electronics such as Max Imagination, Electro Boom, and also Great Score. These three electronics and electrical engineers are great, which I learned my some of my electronic stuff. So I would like you to go subscribe to the channel and also subscribe to this channel. Thank you very much for watching, and I'll see you in the next video. Bye for now.